Good evening. This is a quick video about the Gateron optical switches and how the keyboard that is compatible with these optical switches goes together. So the keyboards that we are seeing a lot of are from this company. I think they call themselves Monkey King or something like that, and they have the keyboards that are iGK61, iGK62, and these PCBs are compatible with the optical switches. And when I say optical, it means that instead of electrical contacts closing the circuit, there is an optical sensor here, and you'll see how it works. So here's one of these optical switches, and they do not have any contacts in them, and so they don't have any pins, and so there's nothing to solder. Instead of that, they have a little protrusion at the bottom of the stem that breaks the light beam when it covers up this little slot in the housing. See how it blocks the light in that little slot at the bottom of the switch housing. So quick look into how these go together. As you can imagine, there's no pins, so something needs to hold the PCB to the plate. So first of all, the PCB attachment to the case isn't like a normal 60% poker case. The screws are actually mounting the top plate to the keyboard to the case. So the case has these sort of like standoffs that are taller. They're like 3.5 millimeters taller or so, because they go all the way up to the plate instead of just going up to the PCB. So these screw locations on the plate are obviously not the standard poker screw locations that most 60% cases use, even though the case itself is a 60% size case. And these optical PCBs are compatible with standard poker mount cases, and you'll see in a minute how that is. It's that the PCB itself has the screw holes for the standard poker locations, but those are not the screws that are used. Those are not the holes that are used when you buy one of these keyboards that comes with a case. So you see here, these I put these in tight, didn't I? Okay, so I'll get these out. Did I get them all? Oh, there's just one more in the middle, I think. I think there's 6. Actually, there's 2 more at least. So there's I think there's 7. Don't ask me why I tightened these so tight last time. Okay. Is that all of them? I think I missed one. Here it is. Alright. Okay, so there's 8 screws that mount the case to the plate. Not bad. Now, lifting this out of here, I'm lifting the front first because the USB connector nestles into the case. Anyway, so this is a case that's designed for one of these optical PCBs. So it has these non-standard standoffs. They're you know, quite a bit taller than usual because they go all the way to the plate. So then the plate is affixed to the PCB with these screws here. There's 1, 2, 3, 4, 5, 6, right? And you'll see here we have the standard poker mount locations. So you could put this PCB into a standard poker case. Sorry, this is one, this is one. So 1, 2, 3, 4, 5, 6. So these are the standard poker mount spots. So you could put this PCB into a standard 60% poker style case, but don't ask me how you would keep the, well, two things. One, you wouldn't be able to reach, if you use the plate that comes with it, you wouldn't be able to reach these screw heads to screw the PCB down to the plate because there are not holes in the plate where the poker mounts go. So if you wanted to, I suppose you could drill through the plate. You could drill a nice big enough hole for to feed the little screw through. But assuming you didn't do that, if you used a standard poker style plate, then you know, how would you secure the PCB to the plate? Because as you'll see in just a minute, and I'm sure if you've looked at one of these before, you realize there's no pins to solder to the PCB. So, and there's also not even hot swap sockets. You know, at least a hot swap socket provides some resistance to the pins pulling out. But here, the centerpiece of the switches fits not very tightly to the PCB. So once I remove these 6 screws, the PCB just lifts right off the switches. So now you can see what they did here is the plate has these standoffs on the underside of the plate itself. So these on the stock plate, I believe, are press fit in, I think. See that? That's where that standoff is press fit into the plate. It's not screwed in, but I suppose if you could get the length just right, you could drill holes in the plate and attach these standoffs to a regular 60% plate. But you know, the height of those standoffs, I'm guessing, doesn't it need to be 3.5 millimeters? I'm guessing. It's not a standard size for a standoff. So let's just double check that. So here, get my calipers out. About 6.5, looks like. And the plate's about 1.5. Oh, never mind, I see. So part of the standoff actually goes through the PCB. So the thinner part of the standoff goes through the PCB. Interesting. Okay. So if you were going to use like a standard standoff, 5.1. I don't think I'm measuring this very well. Let's see here. Yeah, it's about 5. Yep, so minus the 1.5 millimeters of the plate, so you need about a 3.5 millimeter standoff if you wanna use just a typical standoff here between the plate and the PCB. So that's how these optical PCBs go together with the plate. So there's those 6 standoffs. You see how easily the PCB went back onto that plate. You know, no force whatsoever holding the switches into the PCB. So you're completely reliant on these other mount points to connect the plate to the PCB by way of standoffs on the underside of the plate. So if that's the information you're looking for, you don't need to bother watching me put this back together. But I am going to put it back together anyway. Oh, by the way, you might have noticed my kind of sloppy little repair job here. The quality of these PCBs doesn't seem to be super great, because this particular one that I had was sitting plugged into my computer and nobody was touching it, and this little circuit under this wire burned out. This little chip under the wire burnt out, and it was a voltage regulator. So I ordered another one that met the same specifications. Actually, it's capable of more current, so it's a little bit bigger, and it didn't fit in this location. So I just super glued it here and ran little jumper wires. So that's why you have that weird little squid looking mess over there, because this PCB just kind of committed suicide for no reason. But once I replaced that voltage regulator, it's been fine since then. It's actually, I've spent more hours using it after the repair than before it broke. So maybe that was just, maybe the original voltage regulator was defective or something, I don't know. So then this plate and PCB, I know this is kind of a tight fit to get it back into the case. Don't know why. There. That's fine. And you got all 8 of these, which, why the heck do you need 8 of these? I mean, is it just me, or is that kind of overkill? 8 different screws. Seems like you could keep it in there securely with less than that. So if you think about it, this PCB has the standard mount points for poker, which I think is like 6 screws. And then it's got the other, it's got the other 6 holes where you can attach the plate to the PCB, And then it's got big holes for the standoffs to go through. So this PCB has like 20 different holes in it. 8 of them are big holes. 6 of them are little holes. And the final 6 are the standard poker mount holes, which are kind of medium size. So this PCB is full of holes. And the switch orientation has the LEDs at the top, which is kind of interesting because the I think I looked at this before and found that the let's see, I think the dimensions might be symmetrical here, where you could put the switch in upside down. I think the only thing stopping you from doing that is the LED on the PCB. So I think if you were to remove that LED, you could actually pick your switch orientation, whether you wanted your switches north facing or south facing. So that's kind of funny. But, you know, that little guy there is what's stopping you from being able to turn it around. Because the switch housing has a bigger recess on the bottom where the LED goes. There isn't room for the LED on that side. Well, that's all I can think of about these optical keyboards, other than to say that they run their own proprietary firmware, so you can't, so far, you can't put something like QMK on them or modify your firmware. Another interesting feature on these PCBs is the microphone right here. So it's the keyboard that listens to you. Spy keyboard. But no, seriously, others have confirmed that the way this microphone is wired, it's not really possible for the audio to get sent back to the PC and out to the internet or anything like that. So supposedly you don't have to worry about that. You don't need to worry about anyone eavesdropping on you. The function of the microphone right here is the firmware can make the lights react to sound. So anyway, that's the keyboard. That's all I can think of to show about this keyboard. I don't remember how to change the lighting modes, but it's kind of cool. Thanks for watching.